Let's do 5 examples regarding the derivative of trigonometric function. The first one is y equals to the square root of tangent e to the x and then plus cosine to the third power 10x. I want to make a quick note. Cosine to the third power x, the third power is the same thing as you take the third power of the entire cosine. So that one is you find out what cosine of x equals to, and then you take the third power to the result. The result is raised to the third power, which is not the same as cosine x to the third power. This one cosine x to the third power, that one is you take the third power first, and then you do the cosine. What we have right here is cosine first and then third power. This one is third power first and then cosine. You study all of this in trigonometry or in your pre-calculus. Okay, let's go straight to the derivative. So the square root is 1/2 power. So when you do a y prime, I will just bring the 1/2 power down, and then everything is now raised to negative 1/2 power. And then we have tangent e to the x plus cosine to the third power 10x. So what's the derivative of that? The derivative of this by chain rule. So the tangent e to the x, the derivative of tangent is secant, and then e to the x, and then the derivative of e to the x is still e to the x. All right, and then we add, we bring the third power down. So we bring the third power down, and then we have cosine 10x raised to the second power, and then the derivative of what? The derivative of cosine is equals to, oh, by the way, this one I recommend you to put the second power outside. Don't put the second power between the cosine and the tan. If you do so, there is a chance that you will just go to the derivative of 10x. You will just completely ignore the cosine. So the derivative of cosine is negative sine 10x. The derivative of 10x is equals to 10. So this should be in one big square bracket. All right. This one, the simplification, I will just leave that to you. So I will not touch this one. I will have a 1 divided by 2, put the square root in the denominator. So the e won't touch anything. And then I will change the big plus, this big plus to a minus, and then 30. And then cosine square 10x times sine of 10x, and then you can put this one on top of that, because you have 1 divided by 2 times the square root, right? You can put it in a more compact form. Okay, that is the end of the first one. Moving on to number 2, we have function p equals to the cube root of sine square x plus 4x divided by cosine of 5x minus 1. First of all, this one requires a quotient rule. We will be using f prime g minus fg prime. And then I have to remind you that sine square x is equals to sine x. You square the whole thing. All right. So p prime, you bring the 1/3 down, and then you have this raised to negative 2/3, right? Sine square plus 4x divided by cosine of 5x minus 1, and then you have to do a quotient rule. I square the denominator immediately, cosine 5x minus 1 square, and then the top, that is a 2 times sine x. The derivative of sine is cosine, and then the derivative of 4x is equals to 4. Copy the denominator, and then minus the numerator, sine square x plus 4x, and then you multiply the derivative of the denominator, which is what? Negative sine of 5x. There is a 5 in front, and then minus a 0. All right, so that is number 2. And then number 3, we have r equals to x to the 8th power, and then e to the 10th power. I also want to multiply cosine of 4x. This one, there are 2 product rule. I will glue the first 2 terms together, x to the 8, e to the 10, and then treat this as one term, and then I multiply cosine of 4x. So using the product rule, that is fg plus fg. the order of the derivative f first, g second. And then r prime, the derivative of that, I will be treating this as f, and then this is a g. So what's the derivative of the parenthesis? That is a, right? Ax to the 7, e to the 10x, right? 10x, 10x. I don't want to put a constant over there. Times e to the 10x, and then plus x to the 8th times e to the 10x, and then times 10. Chain rule. What else? Yep, this is done, and then you have everything times cosine of 4x. So f prime g is done. So this is f prime, this is g, and then you add f g prime. So you copy this, x to the 8th power, e to the 10, g prime, this is easy, negative sine of 4x, and then there is a big 4 in front. The only simplification I will do is I will take care this plus and this minus. That's it. I won't do anything else because that is unnecessary. Okay, 2 more to go. What's the next one? The next one, let's do something easier. How about this? How about f of x equals to 1 over cosine x? There are 2 ways to do it. So the first way to do it is you walk through the quotient rule. The quotient rule is fg minus fg divided by g squared prime and prime. So f prime, so you get a g squared, so that is a cosine square of x. And then f prime, this is a 0 times cosine, and then minus 1, the derivative of cosine is negative sine. So that gives you a 0, right? So you have a sine of x, and then the cosine, I will just do this. I will just do a cosine times a cosine. And then this, I will just add a 1 in there. So the sine over cosine gives you a what? Gives you a tangent. The 1 over cosine gives you a secant. And then this is your final answer. Another way to do it is you write f of x like that. Cosine of x to the negative 1 power. And then f prime, you bring the negative 1 down, and then cosine x to the negative 2. And then you take the derivative of cosine, which is negative sine x. So that one, the 2 negative is gone. That gives you a sine x divided by cosine times cosine in the denominator. So you will get the same result. All right, so 2 different ways to do it. And then the last one, I want to do a tangent. Let's do a tangent. How about this? Z of x equals to e to the negative 2x, and then minus a times tangent to the 35th power, and then bx plus c. So z prime, you have e to the negative 2x, the derivative of the exponent is negative 2, and then what is the derivative of tangent? Oh, this one you have to bring the 35th power down, right? So you have a minus a, actually 35a, so 35a, and then tangent bx plus c, so you have this raised to the 34th power. So that's why I said when you take derivatives like that, so when you take derivatives like 35th power x, so this one, I recommend you to put the 35 outside first. So 35, and then you bring the power down. So 35, and then you have a tangent 34, and then you times a secant square. If you don't bring the 35 out, so if you keep the 35 between the tangent and the x, there is a small chance, if you are not being careful, that you will miss taking the derivative of tangent. So when you do your homework, pay attention to this. That might make you to miss a term. Okay. Multiply the derivative of this, which is secant square bx plus c, and then multiply the derivative of that, which is just a b. I just did a lot of chain rules, so let me double check. So everything looks good. This one is good. This one is good. Yep, keep the 34 outside so that won't make you to miss the derivative of tangent. And then secant square, yup, everything looks good to me. Alright, that is the last example and also the end of this video. If you think you learn a lot, this is my teaching fits your learning. Give me a like, share, and subscribe, and I will see you all in the next one. Signing out.